Okay, this is part 3 of Unit 6B, and now we're looking at variations in a quantitative way. So this one we're talking about arrival times for airlines. We have 2 airlines have data on their arrival times of their flights. So if you see an arrival time of +2, if my iPad will work. So if you see an arrival time of +2, the flight is arriving 2 minutes early. If you see like a -5, that means it is arriving late. So we've got 2 different airlines here. Okay, now we're working again. We've got Skyview Airlines has a mean arrival time of 0.5 minutes. Okay, and the 0.5 means it arrives early with a standard deviation of 9.6 minutes. So if we do Skyview, the mean is going to be 0.5. The standard deviation is going to be 9.6 minutes. So there's a lot of deviation for Skyview. Then we have another airline, Sky High, has a mean average time or arrival time of -5, so it tends to be late with a standard deviation of 4.0 minutes. So when we look at this, so on average, the Skyview, so we'll just say something like Skyview arrives on time on average, because it's 0.5 minutes, so it's on time or a little bit ahead, but can have large delays because of that large standard deviation of 9.6 minutes. So it would not be abnormal for you to take 0.5 and subtract, one standard deviation, 9.6, and be 9 minutes late. So that standard deviation gives us a lot. It lowers the reliability of that Skyview airline. Now, if we look at Sky High, so Sky High tends to arrive late on average, but it is definitely more reliable because of a smaller standard deviation. Standard deviation is more than half, so it is more reliable, and you can also say greater potential for shorter delays. So, which airline would you choose? I mean, if it was me, even though Sky High averages being about 5 minutes late, its standard deviation tells me that it's going to arrive within kind of in clustered groups of time frames, rather than where Skyview, it tends to arrive on time, but then it's got a huge standard deviation. So that means you could have a lot of planes that are early, you could have a lot of planes that are late. There's a very big spread there, and being it's not abnormal for one plane to be 9-10 minutes late or 9-10 minutes early. So just a lot more deviation there, and so less reliable for the Skyview. Okay, the last one we're going to look at here is some vet data. We have a small animal veterinarian reviews her records for the day, and she's got some notes on 8 dogs and 8 cats. And we want to make a conjecture about these, which has a larger mean, median, and standard deviation. So if we look at the dogs, okay, if you look at the dogs' weights, every weight here on the low end exceeds the cats, and then the biggest weight, 102, is much more than the 22. So the average weight for dogs, I think it's fair to assume that the mean is greater than cats here. And then also, when we look at the median of dogs compared to cats, okay, the median is, we're going to be in here somewhere, and the median here is going to be in here somewhere. Definitely going to be much bigger for the dogs on that one just by inspection. And then now if we look at standard deviation, if we just look at the range, so the range for the dogs is 102 minus 13, so 89, and the range for the cats is going to be 22 minus 4, or 18. And so if we use just that rule of thumb and we take 89 over 4, so 89 divided by 4 is going to be much greater than 18 divided by 4. So the range is going to be, or the standard deviation is definitely going to be much bigger for the dogs, because we're ranging from 13 pounds all the way up to 102 pounds, whereas cats 4 to 22. So cats are more clustered. That data is much tighter. The dogs are much more spread out because we just based off of that information and looking at those ranges. And so that's, upon inspection, that's what we would assume there. So then, if you'd like to, you could go through and I've written these down, but if you want, so the mean for the dogs was 51.8, the median was 50, and the standard deviation was 28.9. And you compare that with the cats. So the mean here was 11, the median was 9.5, and the standard deviation was 7.0. So doing the actual calculations, it definitely shows that the mean and median are much greater for dogs than cats, and also the standard deviation is 4 times more in this case. So that's how you can just kind of analyze, briefly get ideas, and then you can obviously go to technology and get the exact values on that, or approximations. But that's just how we would look at it upon inspection, what we're seeing there firsthand. So that concludes Unit 6B. If you have any questions, please do not hesitate to ask, and appreciate your time.